This is lesson 6.4. And before we get into 6.4, I just want to review the properties of parallelograms. So if you have a figure that is a parallelogram, the things that we know is that by definition, that opposite sides are parallel and opposite sides are congruent. And we know that opposite angles are congruent. We know that, let's see, the diagonals bisect each other. And we also know that the consecutive angles are supplementary. So guys, if it says that you have a parallelogram, all 5 of these are true, okay? So you can just apply those. So let's look at 6.4. In 6.4, we're going to talk about special parallelograms, and that would be a rhombus, a rectangle, and a square. So the definition of a rhombus is it's a parallelogram. So all the properties of parallelograms are true: opposite angles congruent, opposite sides congruent, etc. So a rhombus is a parallelogram that has 4 congruent sides. So I want you to draw one and mark that the 4 sides are congruent. Now, not all parallelograms have congruent sides. Like I could draw this one like this. This is a parallelogram, but not all the sides are congruent. So this is not a rhombus. That's not a rhombus. Okay, so the next one is a rectangle, and a rectangle is a parallelogram with 4 right angles. So guys, here's the thing. Let's say that you are told that you have a parallelogram, and you're given that this angle, I'm going to call it A. If you're given, you know it's a parallelogram, if you're given that angle A is a right angle, well, because it said it's a parallelogram, opposite angles are congruent. So you know that angle C would be a right angle too. You also know, because it's a parallelogram, that angle A and B add up to 180. So if this is 90, this would be 90. And angle A and D add up to 180. So that would be 90. So if you're given a shape and you're told it's a parallelogram and you are given just one corner, then you know that all the corners are 90. Okay?
Hey, Miss Eischens.
Hi, Kyler. Did you find Mr. Jensen?
No, I just got back from meeting.
He was going to go look for you. Go look for him. He was going to go to the gym. So check there and see if he's down there. If not, he's in Mrs. Loft's room. You can go over and see him. But he has your test to go through with you to help you so you can retake.
Okay.
Oh, bingo. We got a match.
Okay.
Do you guys want to take desks in the hall and work on that?
Sure.
Okay, awesome. Okay, next one, guys. A square is a parallelogram with 4 congruent sides and 4 congruent angles. So a square is also a parallelogram, and it has 4 congruent sides, and it has 4 right angles. Now a square, because it has 4 congruent sides, it's also called a rhombus. Or it is also a rhombus with 4 congruent sides, and it has 4 right angles. So a square is also a rectangle. So a square is a rhombus and a rectangle. Okay, so some corollaries, which are kind of like spin-offs from theorems, The first one is a rhombus corollary. A quadrilateral is a rhombus if and only if it has four congruent sides. So if a quadrilateral has four congruent sides, then it's a rhombus. And if a quadrilateral is a rhombus, then it has four congruent sides. You can read it both ways because if it's an if and only if. Same thing with a rectangle. A quadrilateral is a rectangle if and only if it has four right angles. And the last one, we just talked about that. A quadrilateral is a square if and only if it is a rhombus and a rectangle. So if you have a quadrilateral that is both a rhombus and a rectangle, well then it's also a square. Have that down? Okay. All right, so now this is a Venn diagram, which is kind of helpful here. So in the whole box, everything in the whole box here, those are all parallelograms. Now, you have some special ones. You have rhombuses. Those are parallelograms. So all of these have congruent sides because they're rhombuses. All right. And then over here we have rectangles. All of these have right angles. Okay. And now just the one here in the middle has both congruent sides, congruent angles, all right angles, and then it's all the properties of a parallelogram. So we're going to use that chart and we're going to do some activities right now. This is going to be fun. So first, what I want you to do, you have to use some reasoning for these problems. So these are sometimes, always, or never. This isn't in your notes, so just watch up here. It says a rhombus is sometimes, always, or never a parallelogram. So is a rhombus sometimes, always, or never a parallelogram? What would you say, guys? Who feels brave today? Okay. Somebody online, I just heard it in class here with somebody. Somebody online, what do you think? Is it sometimes, always, or never a parallelogram? Always. It's always, because everything in that chart is a parallelogram, so that would be an always. Good, always. Next, a square is blank a rectangle. So if you have a square, is it sometimes, always, or never a rectangle? Yep, that's going to be another always. I always have to check my phone in case I have a student, but it's not. It was just a bill coming in. So a square is always a rectangle because a square always has four right angles, which that's a rectangle. The next one, a rectangle is blank a rhombus. So is a rectangle sometimes, always, or never a rhombus? Do you have any rectangles that cross over into the rhombus world? What do you think? Is a rectangle always a rhombus? Does a rectangle always have four congruent sides? No. Can it have four congruent sides, a rectangle? When does it have four congruent sides? When it's a what? Yes, when it's a square, then a rectangle is a rhombus. So here you would say sometimes. Okay, when it's a square. All right, I'm going to pause my recording for a second. All right, so let's look at this example. This is not in your notes, but let's look at this because this is the type of problem you're going to have to, or the type of thinking you're going to have to do in this lesson. It says, is parallelogram ABCD a rhombus, a rectangle, or a square? Okay, so here's the thing. That symbol is for a parallelogram, which means that opposite angles are congruent, consecutive angles are supplementary, opposite sides are congruent, so all of that. So looking at ABCD, that's this right here. Is it a rectangle, a rhombus, or a square? Who knows? What's that called? ABCD. Who can tell me? Is there life on the other side? What would A, B, C, D be? It would be a rectangle. Now we can talk about why would you know that? Because they're only given one angle. Well, because it's a parallelogram, consecutive angles are supplementary. So this one plus this one equals 180. So this has to be 90. Opposite angles are congruent. So it's a rectangle. Okay, the next one says is parallelogram EFGH. So that is this one, EFGH. Okay, so they only tell you that this side and this side are congruent. However, it's a parallelogram, which means opposite sides are congruent. So this side and this side are equal, and this side and this side are equal. That means all the sides are equal, so it would be a rhombus. So we had to use the reasoning about what we know about parallelograms to answer that. Okay, now these next problems, you're going to do a load of these problems, okay? So you got to pay attention. It says for any rhombus QRST, decide whether the statement is always or sometimes true. So what I would first do is draw a rhombus and label it QRST. Now remember, a rhombus has all sides congruent. And then label the label in order here, consecutive order. So now our Q and S sometimes, always or sometimes, let me see, decide whether the statement is always or sometimes true. Oops, I marked the wrong one. Let me go back here. So it says Q and S are congruent. Is that always true or sometimes true? What do you think? Are those two, if it's a rhombus, are the opposite angles always going to be congruent? No. Look at this. Well, wait a minute. Let's think about this. Okay, do you see this picture right here? Okay, these are examples of a rhombus because this side, and this side, these four sides are all congruent. Opposite angles, if you watch it, the opposite angles are going to stay congruent. Guys, it's a rhombus is a parallelogram, and parallelograms have opposite angles congruent. So this would be always, because it's a parallelogram and opposite angles are congruent. So that one is always. Now this next one, we know that it's a rhombus. Now it says, okay, decide whether the statement is always or sometimes true. So is it always true that Q and R, which means they're two angles right next to each other, that they are congruent? Well, look at just this example I'm showing you right here. Can you see me? Is my video working right now? Can you see a picture of me? Okay, mine is just being really goofy. So here's the deal here with this, guys. In this case, if you had like a rhombus that looked like what I'm showing you, this angle up here is very small. It's acute. The one next to it is obtuse. So in this case, no, that's not a true statement. However, if you stretch this out, and we still have a rhombus, and now if I make one of them 90 degrees, what's this one going to be? If this is 90, this would have to be 90. So in the case that this is a square, and if this is 90, then this one would have to be 90. So the two consecutive angles are they're sometimes congruent. And that is when it's a square. All right, next. For any rectangle, EFGH, is it always or sometimes true that FG is congruent to GH? Explain your reasoning. First thing I do is draw myself a rectangle and label it. Just give me a couple minutes and I'll get you that test ready, okay? Okay, is it sometimes or always true that FG, which is this side, and GH, are those congruent? Well, by the way I drew it, it's not always true, because in that figure it certainly is not. But could those two be congruent? And if so, when? We know that it's a rectangle. In what case would this side and the side next to it be congruent? What shape would it have to be? A square. So again, that is a sometimes. And that would be in the case where you have a rectangle, EFGH, which is also a square. Because in that case, FG and GH are congruent. All right, next one. We have a few more properties. A parallelogram is a rhombus if and only if its diagonals are perpendicular. Next, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. And then I'll let you write the next one down. A parallelogram is a rectangle if and only if diagonals are congruent. You can sit in the hall if you want. Or do you have a question? Okay, can't you turn it on? Oh, bingo. Okay. Okay, guys, so here's the thing. Let's go back to the top here. If you have a rhombus, that's a parallelogram, which means the diagonals bisect each other. But in the case of a rhombus, they are also perpendicular. So all four angles here are 90 degrees. So we're going to have some fun with that. And not only do we know that they bisect each other, we know that they bisect the opposite angles. So these two are the same. So like if this was 60 and this was 60, these two would both be 60 and 60, which is 120, which means these C and B are supplementary. So that would be 60 altogether, which would make 30 and 30. And then opposite angles are the same. So that happens with a rhombus. So with a rhombus, diagonals are perpendicular, they bisect opposite angles, and they bisect each other. And then lastly, with a rectangle, diagonals are congruent. So the distance, if you have a rectangle, okay, we have a rectangle, the distance from A to C is the same as the distance from D to B. They're congruent, which means all of these are congruent, which means, even more fun, if you look at this triangle right here, what kind of triangle is this? This little one that I have yellow, what would be another name for that triangle? It's what? If two sides are congruent, what kind of triangle is it? Two sides congruent. Do you remember?
Two sides that are congruent?
In a triangle, what's it called?
Oh,
Starts with an I.
isosceles.
Isosceles. So it's kind of fun. These you can have a lot of fun with because you end up with 4 isosceles triangles. So anyway, just keep that in mind. All right, let's do some application. You're building a frame for a window. The window will be installed in the opening shown. The opening must be a rectangle. Okay, big issue there. If you're trying to put in a window, you need a rectangle or you have a lot more work to do. Given the measures in the diagram, can you assume that it is? So this is what we're given here, guys. We're given that this is 44 and this is 44. So these sides are the same. And this is 33 and that's 33. Is that enough that you would know that you have a rectangle? What do you think? I hear a yes. What do some other people think? If opposite sides are equal, do you know that it's a rectangle? What shape did we talk about that has the property that opposite sides are congruent? Which one did I tell you that is true for? Do you remember? Very first beginning of this. Parallelograms. Parallelograms, that's what we know that opposite sides are congruent. Now here's the deal, guys. This could be this figure. I'm going to just draw it slightly. These are both 33. These are both 44. So opposite sides are congruent. But do you have a rectangle? No, you can clearly see that's not a rectangle. Now this looks like these are 90 degrees, but again, you can't go by looks. Because if this is 88 degrees right here, your window's not going to fit, right? So that doesn't work. You can't go by opposite sides because even though they look like it, you can't go by it. You need a measurement. But let's look at the next example. You measure the diagonals of the opening. So you measure from here to here, and you measure from here to here. One of the diagonals is 54.8. The other one is 55.3. What would you conclude then? Do you have a rectangle if the diagonals are different? Go back to this slide. It said a parallelogram is a rectangle if and only if the diagonals are congruent. So the way that you would know, like you don't even need a tool to measure your corners. If you measure the diagonals, and if this one was 55, and if this one was 55, you would know that you have a rectangle. So that gets used a lot in building. All right, because if the diagonals are equal, then you have a rectangle. Okay, let's do some other problems here. What are the measures of the numbered angles in a rhombus? Now, first of all, guys, let's talk about the diagonals of a rhombus. So remember, if it's a rhombus, the big thing is opposite sides are, or all the sides are congruent. So the diagonals, they bisect each other because it's a parallelogram. They bisect the angles, opposite angles, and they are perpendicular. Using those properties, we can fill these numbers in. So this right here, we know that this is 90 degrees. We know that this and this are both 58 because that's bisected. And opposite angles, so angle B and D are the same. So these are both 58. So you fill that all in. Now there's only one that we're missing, and that's angle 4. And we have a triangle. We know that one is 90, one is 58, so that's 148, and you subtract that from 180. So you get 32, right? So that's how you do those problems. Next, what are the measures of the numbered angles in a rhombus? So a couple ways you could do this. I hadn't thought of this yesterday when I did this lesson, but all the sides are congruent. So like if you look at this triangle, this is an isosceles triangle. So you can take 180 minus 104, and that gives you 76. So these two angles are 76 divided by 2, which is what, 35 plus 338. Those are both 38. And we know that the angles get bisected. So if this is 38, this one's 38, and this one's 38. And these are fun because there are different ways that you could have figured it out. You could have said, well, angle Q and S are the same, and then worked in a different direction. All right, so I'm going to end this video, and let me know if you have questions.